Hi, Algebra 2 students. These notes are on solving radical equations, and all the examples I'm doing are going to be off of the worksheet that we were working on in class called Exploring Solving Radical Equations. Looks like this. So you could take these, write down these examples kind of next to where you did your work on the specific problems on this worksheet, or if you'd rather, you could just take notes like normal in your notebook if that's where you think you'd rather have your notes. But I'm fine with either version. So quickly, before I get into the examples, I just wanted to kind of review two big ideas, which is if we have something inside of a radical, I'm going to call it just x, and we have some like the nth root of x. What we were noticing in the exploration was if we want to cancel out that root or get x by itself, right, we would have to raise that to the nth power, and then the nth power and the nth root, or which is 1 over n, will cancel each other out, so we'll be left with just an x. The other pattern we were seeing is if you have x raised to a rational exponent, say n over m. If we want to cancel out that root and get x by itself, or x to the first power, well, we would need to raise this to the reciprocal power, m over n. Because when I multiplied those two roots, I'd get mn over mn, which is 1, right? So that cancels, and then this also is x. So these are kind of like our two strategies, right? And in general, when you see an equation with a radical, we'd like to get the radical part by itself on one side before we think about doing one of these rules. Okay, so let's take a look. The first example, I'm going to call it example 1 for notes. It's actually problem number 8 on the worksheet. And it is the cubed root of 2x plus 7 is equal to 3. So the idea is, well, if I want to get rid of a cubed root, right now my radical is by itself. There's nothing like outside the radical on the same side of the equation. So I'd start by raising this to the third power. And I also need to raise the 3 to the third power. So now this is going to become on the left 2x plus 7. Because the root and the radical cancel. And on the right, 3 to the third power is 27. Now, you might be able to just kind of take a quick look and figure out what x has to be. You can just, using your basic ways of solving equations, subtract 7. 2x is equal to 20. Divide by 2. And we get x is equal to 10. Now, in all of these problems, as I stressed in class, you must check your work. Because sometimes you end up with an extraneous solution. Because we are squaring and square rooting, we sometimes get a value when we go through that process that does not actually work. So in this case, my check would be simple. I'm doing the cubed root of 2 times 10 plus 7, and I'm hoping that equals 3. And 2 times 10 is 20. The cubed root of 27 is 3, so that checks out. Okay, it doesn't take that long to do the check, but you do need to do it. So let's look at the next problem. I'm calling this example 2. It is also number 9 on the worksheet. It says 4x to the 3 halves is equal to 108. Okay. So now, before I go about trying to cancel out the 3 halves, I need to get the radical or the rational exponent by itself. And right now there's this 4 out front. So the first thing I'm going to do is divide out by that 4. Now I have x to the 3 halves is equal to 27. All right. From here, now is when I would want to cancel out the 3 halves by raising this to the 2/3 power. And then on the left-hand side, I'm left with just x. On the right-hand side, I need to actually figure out what is 27 to the 2/3. So the easiest way to do that would be to split the 2/3 into a 1/3 and then raise to the 2. And obviously, if we multiply that back out, we get the same 2/3. So I'm going to do 27 to the 1/3 power, which is 3. And then I'm going to do 3 squared. And then I get my answer of 9. So now for my check. My check looks like, okay, plugging in 9 for x. and checking to see if that actually does equal to 108. So I'm going to do 9 to the 1/2 first and then raise it to the third. So 9 to the 1/2 is 3, and 3 to the third is 27. And 27 times 4 is 108, so that checks out. All right, moving on to the next example, which is number 10. We have x plus 2 to the 3/4 is minus 1 is equal to 7. Okay, so in this problem, I don't have the radical or the rational exponent piece by itself, right? So the rational exponent piece is that, and right now there's this 1 on the same side of it as it. So I'd like to move that 1 over to the other side first by adding it. And now I have x plus 2 to the 3/4 is equal to 8. From there, now I'm going to cancel out the 3/4. And the way I do that is raising it to the reciprocal power. So that would be 4/3. Whatever I do to one side, I do to the other side. Okay, on my left-hand side, these will cancel. We'll be left with the x plus 2. And on the right-hand side, I'm going to split that up into 8 to the 1/3 raised to the 4th power. Because that's easier for me to do in my head. So 8 to the 1/3 is 2. And then I would do 2 to the 4th power, which is 16. And now this is a very easy equation. I just have to subtract the 2 over, and I get x is equal to 14. The last step will be to check my work. So 14 plus 2 raised to the 3/4 power minus 1, checking to see if that equals 7. So that would be 16 to the 3/4. So 16 to the 1/4 to the third, minus 1, minus 1. That would be 16 to the 1/4 is 2, and 2 to the third is 8. So we have 8 minus 1 is 7, and that checks. Okay, so now for example 4, that is going to be number 11 on your worksheet. Which is x plus 1 is equal to the square root of 7x plus 15. So in this problem, I'd like to I want my radical by itself, and it is by itself, right? So the idea is I have the square root on one side by itself, so I'm going to start by squaring it to get rid of the radical. So on the right-hand side, it's simple. When I square, it cancels out with the root. I'm just left with what's inside. On the left-hand side, though, I actually need to do x plus 1 quantity squared, which means multiply x plus 1 times another x plus 1, which means FOIL or box method or however you multiply binomials. So if I do x plus 1 times x plus 1, that becomes x squared plus 2x plus 1. Okay, and now this is a quadratic equation that I can think about solving. So if I'm going to solve it by factoring, which is my usual go-to first try is factoring, since a is 1, so right? So first I need to get it equal to 0. So I'm going to subtract, actually I'm going to use the other color. I'm going to subtract 7x from both sides, and I'm also going to subtract 15 from both sides. I'm going to just do that in one step to save myself a little bit of time. So I'm going to get x squared minus 5x minus 14 is equal to 0. Now, to factor that, I need something that multiplies to negative 14, adds to negative 5, and that would be negative 7, positive 2. Setting each factor equal to 0, we get either x equals 7 or x equals negative 2. And now I do want to check my work. So when I check, I get 7 plus 1 is equal to the square root of 7 times 7 plus 15. So is 8 equal to the square root of all that? Well, this is 49 plus 15, which is 64. So it looks like that will check out because I know one of the square roots of 6 is 8. Doing the other one, I have negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. So I get on the left-hand side, I have negative 1. On the right-hand side, I have negative 14 plus 1, or plus 15, which is 1. So I get negative 1 is equal to the square root of 1. Well, I know the square root of 1 is plus or minus 1, right? So this does check out because one of the two square roots of 1 is negative 1. So both of these solutions work. Okay, now we have one more example for you, which is number 12 from your worksheet. This is example 5, number 12 on the worksheet, which is the square root of x plus 2 plus 1 is equal to the square root of 3 minus x. Now this one is a little bit different because there's two radicals now. There's one on each side. And the issue becomes like we can't get both of them by themselves on one side because one of the two is always going to have that plus 1 on the same side as it, right? So there's no like nice place to put that plus 1. We just kind of have to deal with it. And the way we deal with it is we are going to square both sides to get rid of the square root. Okay, so it gets rid of our square root nice and cleanly on the right-hand side. We're just left with the 3 minus x. But on the left-hand side, I have to do a little bit more work, which I'm not crazy about, but it's not hard. The idea is if I'm squaring this thing, that means I'm multiplying it by itself. So I'm doing, just kind of to clarify, that's all the problem. Okay, I'm doing the square root of x plus 2 plus 1 times another square root of x plus 2 plus 1. Sorry, I just wanted to get that out. So this thing is all equal to 3 minus x. Now, to do this, I actually need to FOIL this out. So if I do root x plus 2 times root x plus 2, I get x plus 2. If I do root x plus 2 times 1, I get the square root of x plus 2. If I do 1 times the root x plus 2, I get that same thing again. And then if I do 1 times 1, I get 1. Okay, now this might look kind of crazy, but there's some nice things that are going to start happening. One nice thing is that we have two of the same radical. So that's like combining like terms. So that's like doing 1 root x plus 2 plus another root x plus 2, so that becomes 2 root x plus 2. And then I can also combine the 1 and the 2. To be plus 3, and then I still have that x out front. Okay, so from here I still end up with a radical, but I'm closer to my answer because I started with 2 radicals, now I only have 1. So the next thing we're going to do is get this radical x plus 2 by itself on one side, and then we'll be able to cancel it out using squares again. So if I'm trying to get this by itself, I'm going to have to subtract the 3, subtract the x, and then divide out by that 2. So I'm going to do the subtraction first. So these x's cancel, these 3's cancel, and I have 2 times the square root of x plus 2 is equal to 3 minus 3, that cancels. Negative x minus x is negative 2x. From there, I need to divide out by the 2 out front. And then I have the square root of x plus 2 is equal to negative x. From there, now I have my root by itself, so I can square it to cancel it out. And whatever you do to one side, have to do to the other. So when I cancel out my root, I have x plus 2 is now equal to negative x squared is positive x squared. Now, this is a quadratic equation. How do I solve it? I'm going to try to factor. So if I'm trying to factor, I need to set it equal to 0. I'm going to move over the x and the 2. And I'm moving these over to the right, because I'd rather have my x squared term be positive if I'm trying to factor. It's easier to factor when a is 1. And if I move this x squared over to the left, a is now negative 1. Okay, so this looks like it's going to factor, because negative 2, negative 1 would be negative 2 and positive 1. So from here, write out my two factors, which then lead me to say x equals 2 or x equals negative 1. I know this was a little bit longer than the previous ones, but we're still not done because we need to check. So the check is plugging in 2, plugging in negative 1. So when I plug in 2, I get 2 plus 2 inside of a root, plus another 1 is equal to 3 minus 2. So on this side, on the left, I'm going to have 2 plus 2 is 4. Square root of 4 is 2. So I get 2 plus 1 is 3. But on the right-hand side, I get 3 minus 2, which is 1. And then the square root of 1 is just 1. So does this match up? No. Right? This does not check out because 3 is not equal to 1 or negative 1. And so this 3, then what that means is this would be an extraneous solution. And for the second one, let's see if the negative 1 checks out. So we'd have the square root of negative 1 plus 2 plus 1 is equal to the square root of 3 minus negative 1. So on this side we have the square root of 1, which is 1 plus 1, 2. And on this side we have positive 4 in here, right? Because minus a negative is plus, so the square root of 4 is 2, and that checks out. Okay, so then the negative 1 is the right solution, but 2 is not. And that's the reason why it's so important to check our work in these problems, because sometimes we do end up getting something that does not work when we plug it back in. Okay, so we will be practicing this in class tomorrow. And for your homework, I would like you guys to then try to complete number 13 on your worksheet, which is to write a description of the process. And then for the practice, just do A through C. And don't worry about D, E, F, and G. We'll do those ones tomorrow in class.